Hey everyone. In the next couple of videos, I'm going to be giving my reviews on the Tuition Center Maths, Physics, and Applied Maths mocks that they released last week. Now, I couldn't do them last week for the fact that I had oral surgery, so I pretty much wasn't able to speak, so that's why I'm only able to do them now. I ideally wanted to do them last week when they came out, just so I could have a very direct response, but here's my response. So, I have briefly looked at the questions just kind of skimming through the topics, but I haven't actually looked at the questions in any sort of detail. And as well, I'm not paid by the tuition center or anyone. These are completely unbiased reviews by someone who's been tutoring maths for the past 4 or 5 years. So this is the maths paper one. It's fairly nicely formatted, I will say. You know, all the exams that I make, I wish I formatted these like that, but as I never. Question one, standard inequality questions, fairly straightforward, and an inverse, yeah, not too terrible, and then a nice simple log equation. Is that all? That's all the question one. Okay, yeah, it's three nice questions to kind of ease you into things. It's very good. Okay, derivatives given by that, use that identity to find f of x. Okay, that's just hiding some integration in there. But these are standard formulas. I mean, if you do applied maths, you could just use u sub here and then make things easier, but these are all in the log tables. And then, I haven't actually seen much inverse trig differentiation on exams before, so it's nice to kind of throw that in. Oh, yeah, I remember this one. This was. I'll kind of just zoom in just in case people can't see it. That's just a ridiculous question. Proven by induction that really annoying looking expression is divisible by 100. You do just have to use the standard, uh, yeah, sort of the standard techniques of n equals 1, assume n equals k, and then prove true for n equals k plus 1. It's just, they are big numbers, so I can understand if students had an issue with that question. All right, question three. Yeah, the triangle inequality is actually really nice to prove. It does say or otherwise. There is actually a much faster way of showing that this is true just by inference. Or not inference, by hindsight. So if you know that the square of any number is greater than 0, you can kind of reverse engineer this and hence or otherwise show that that is true. Yeah, again, just move that to the other side and you have a perfect square. Use identity, yeah, that's standard de Moivre's theorem stuff. Okay, good. And throwing an integral in there. Okay, fun. Integral of cosine cubed, that's just the real part of this. Or, sorry, yeah, no, it's given to us here. So, yeah, you just replace cos cubed with cos 3 theta to take away cos 3 theta, take away 3 cos theta over 4. And you're effectively just integrating that between 0 and pi on 2. Okay, simplify that expression. Yeah, it's fine, hence find that to the power of 9. I presume this simplifies nicely. Although, in fairness, I'm not sure why you'd straddle complex numbers over two questions. It's not really something that happens an awful lot. Like, complex numbers is usually its own question, its own little 30 marker. So a bit of an odd choice to split it between two parts here. Okay, and really just not using the standard nomenclature of using BI instead of IB. So I'm not sure why that's there. And then this is just a question that's come up before of a thing called the roots of unity that I've done several times with my own students. Okay, factor theorem questions, not too bad. The factor theorem questions tend to be nice. Okay, that's an interesting first principles. Definitely, a lot of numbers again to deal with, but something that you should be okay with if you've done first principles enough. Okay, sequences is making another appearance. People got really mad when sequences and geometry came up in paper 1 in 2023, so I'm not sure why they're still putting it here. um, Although I actually know in hindsight it's not really geometry based, but it's kind of just geometric, well, not geometric sequences, but sequences involving geometry, which are in themselves a different kind of geometric sequence. So I mean, it's a fairly nice one, but again, something very standard, and then the sum of a geometric series. Okay. So in terms of the short questions, I think there was definitely something for everyone. I mean, if you didn't like complex numbers, you were pretty screwed because you had to sacrifice. Well, you had the choice of leaving out a question, but you had to leave out a half a question if you weren't okay with the Moivre's theorem. And some of the algebra you might have got caught up with just with all the big numbers, essentially. So, I mean, I wouldn't give it praise, but at the same time, I wouldn't like complain too much about it, if that makes sense. It's kind of just a middle of the road section A, I would think. Okay, section B, right, we have geometry appearing again in paper 1 for whatever reason. And I mean, that just pisses me off, the fact that they use a lowercase v for volume. Okay, great. Yeah, similar triangles and stuff shouldn't really appear on paper 1, or ideally shouldn't. I think one appeared in a related rates of change question involving a someone running away from a street light or something. But yeah, it should ideally be left to paper 2. That's kind of what it's for. Should a dv by dh is that? Yeah, that's fine enough. Wait, they also include the volume of a cone. Okay, that's not really something you include. You expect students to look at the log tables and find it. So I mean, I guess they're trying to justify, here's the formula. We've made it slightly less difficult, which I think, it's not really great reasoning if it is, but here's whatever. Should I dh dt is that? Yeah, it's fine. Was the rate of change of the volume with respect to time? Well, what are we given? We're given dh dt, and we're given dv dh. So yeah, we can find dv dt. Ground stuff. What on earth is this? They bloody threw an applied maths question in here. Oh my god. dl by x equals cosine of theta. Yeah, possibly. I mean, you're probably gonna get. Well, you're not gonna get sine here, are you? Okay, that's wow. Applied maths is appearing here. Okay, so the dl dt equals 3 cosine theta. Okay, they have lt and theta. Okay, not really like standard to include 3 variables in a differential. Like, where are you gonna really go from there? Okay, well that was a bit of an odd question. What about soap dispensers? And what about a mining truck or something? Sure. I mean, I'll give my full review of section B at the end of once I cover all the questions. Question 8: particle shot vertical upwards. Again, another fucking applied maths question. Like, seriously? Find the maximum height above ground reached by the particle. Like, if you didn't know the physics of the fact that, oh, the velocity is 0 when it reaches its maximum height. Oh, actually, well, no, in fairness, for the fact that that's its displacement, the maximum height well, sorry, let me take that back. You can intuitively think that the maximum value of that function occurs when its derivative is 0, which is when its velocity is 0. Okay. Roundabout way of finding it. Find the velocity of the particle immediately before it hits the ground. Yeah. I mean, no units, like, seriously. I mean, I presume in the marking scheme they're going to list, um, how many marks are lost if you don't include units. Like, the units clearly here are meters per second. So, I mean, students shouldn't really have a bother with units by this point, especially my own, or the fact that I say it quite a lot. The fact that including units is very important. Okay, acceleration. Yeah, okay, now they include the units for whatever reason. Oh, dearie me. Solar powered phone charger. Okay. Kind of dissipating the topics here for whatever reason. Two calculus questions kind of in one is a bit not great. Uh, I mean that you can kind of intuitively see how that's formed with the fact that the pi over 12 comes out, but like that's, I don't actually understand what they're trying to get at here. Uh, okay, that's an interesting question. I mean, what time is it right now? It's like 20 to 11, so I'm not fully awake enough to answer the question and think about how to do it. Um, I mean, there are marking schemes and video solutions going through this anyway, so there's no point in me making a video on it if there's videos on it already. Okay, question 9, financial maths. Earth, maybe. Bobcat. Okay, that's the teachers trying to be funny. Okay, typical. Monthly repayments. Yep, sum of geometric series. Grand. Using amortization. How much? 20 years. Okay, so they're kind of forcing you to use one method here and then another method later. The SEC don't really let you do that. They kind of just say hence or otherwise, or kind of just leave it to the student. But I guess it's nice to show that there's other methods to it. I mean, I presume that that's just subtraction. Okay, this question is just a direct carbon copy from last year's paper. It's some amount e to the sum power of t, ask you to calculate a value and then work out the annual rate of interest. So I think that's being very unoriginal of them. If students had practiced the past papers, they would have seen a question pretty much exactly like this. So I don't think it's really fair including it here. Like, you really have to test a student's overall ability instead of just remembering the format of previous exam papers. So poor work on their end. And question 10, another thing of calculus. Are you mad? More calculus stuff. Every question here has involved calculus. If you didn't do calculus by this point, you were screwed. And again, involving cones. Like, seriously? Like, legitimately? More cones? What is it with this man and his cones? Volume of changing, find a rate. Yeah. Okay, now we have geometry coming up again. X and Y be the dimensions, so that Y is that. Okay. Find the value of X. Again, more calculus. What is going on? Is that it? Is that just the end? Because, I mean, nothing else is loading, so I presume that that's the end. Yeah, page for extra work. Is that just kind of the whole thing? Do you get 4 extra pages? Or is there like a copyright notice on the back or something? No, there's probably genuinely like 4 or 5 pages of extra paper. Okay, I'm not sure why it's really slow for some reason. Okay. Right. Overall review of the paper. If you hadn't done calculus or complex numbers, you were absolutely screwed. This paper, like, yeah, if you hadn't done calculus, you were just honestly screwed. Now, calculus, of course, is it's a fundamental part of the course, so you really should be doing it. But if you weren't, like, all that comfortable with it, having that many questions on calculus seems a bit overkill. In terms of section 8, I thought it was okay, but again, the 2 complex numbers questions straddling, like, that shouldn't really happen. So I think overall, I mean, it's nice that they're making the effort, but I think, in my personal opinion, this paper I would give probably about a 4 out of 10. I would just pass it. Like, it really doesn't test like a student's full ability. This seems to be geared towards the very high achieving students who really want the H1s, which, fine, but you have to also consider the people who just want to pass and get those 25 extra points. So let's see what paper 2 brings us.